Here we are doing question 4 of the mixed exercise 3, year 2, pure sequences and series. It states that un is equal to 3 times 2/3 to the power n minus 1, and they want us to find u1. So that is 3 times 2 over 3 to the power 1 minus 1. 3 times 2 here is 6. 3 times 2 there is 6 over 3, which of course is 2, and 2 minus the 1 is equal to 1. Okay. Looking at the next one, we have got 3 over 2 over 3 squared minus 1. So as we go look at this, 2 over 3 squared becomes 4 over 9. Timesing it by the 3 gives us 12 over 9 minus the 1, which is minus 9 over 9, 12 over 9. That leaves 12 take away 9 is 3 over 9, which is 1/3. Okay. What do we have for this one then? 3 over 2 over 3 cubed minus 1 is equal to 8 over 27. 3 8s are 24. 24 over 27. Take away 27 over 27. 7, 8, 9, 10. 3 over 27 minus 3 over 27 minus 1/9. Okay. Right, that's that. What do we have for the next part? Show that the summation of n equals 1 to 15, un, is equal to minus 9.014. Okay, so let's put in a un for there. Okay, so we've got the sum of n equals 115 un, which is 3 times 2/3 n minus 1. Now we don't really have a good way of dealing with that because of the minus 1 on each time. But what we can do is we can separate that up into the 15 and the n equals 1. Because it's separated with a minus, we can say 3 times 2 over 3n minus the summation of 15n equals 1 of 1. Okay, now that whole bit there will be 1 plus 1 plus 1, 15 times. So that whole thing just becomes minus 15. Okay. This bit here, we've got a constant to the power and multiplying by the 3, which could step out. Okay. Which is the sum of a geometric series. Okay. And so we can use on that the Sn is equal to the start term times by 1 minus the ratio n, all divided by 1 minus r. So putting that in, okay. If we had the start term here of this, when we put n equals 1 into it, we get 3 times 2/3, which is 2. So we have 2 times 1 minus the ratio is 2/3, okay, to the power of 15, okay, divided by 1 minus 2/3, and we'll be taking away 15 from that. Okay, so with that in there, Okay, what do we get? Set the calculator up. 2 times 1 minus 2/3 to the power of 15, bracket. 1 minus 2/3, of course, is 1/3. And that gives us 5.9862 minus 15. Taking away the 15 gives me minus 9.0137. I think they had it to 4 significant figures, which of course would round up with the 3 to the 4. Okay, minus 9.014. 4 significant figures. Done. Okay, so yes, just a geometric in there. Right then, prove that, part C, prove that un plus 1 is equal to 2un minus 1 over 3. Now we know what un is, so we should look at maybe looking what it is. So if we've got un, what is un minus 3? Where has my green pen gone? There it is. Okay, so let's have a look at what un plus 1 looks like. That would be 3 times 2/3 n plus 1 minus 1. Can we make that look like this top bit? Don't know. We've got powers here that are adding, which means we've got the same base, 2/3 to the power n, multiplying the same base to the power 1 minus 1. That's multiplying the 2/3 to the power n, which means we can do 2/3 times the 3. 2/3 of 3, of course, is 2. We've got 2/3 n, put it like that, minus 1. Okay, if you consider that 2/3 to be an x, you've got 2x to the power n minus 1, and you can see there that we can't do anything with it. Okay, so where do we go next? All we know about that is it is equal to un plus 1. Okay, doesn't look anything like what we wanted. So let's consider what this looks like. Okay, that is un plus 1. And so if I start with 2 and I put un into it, I get 3 times 2/3 n minus 1 all over 3. A bit messy, but let's see what we get here. Let's start multiplying it out. 2 times 3 is 6. 2 times 3 is 6 times 2 over 3n minus 2 minus 1 on the end is still being divided by 3. So we've got 6 2/3 n minus 3 all over 3, which of course is dividing by the 3, 2 2/3 n minus 1 dividing by the 3. They are both equal to un plus 1. Okay, finished, done, proved.